Okay, so first we're going to write this in the form that our partial fractions would normally be in. So I'll write out the original question again. And it's going to be in the form a, so some number over x plus 1, plus b, some other number over x plus 2. So this is a form that you will get used to writing things in. And if you think about what we've done previously, which is adding together two algebraic fractions, then it's the same process but in reverse. Okay, so the next step is to multiply both sides by the two denominators that we've got on the left-hand side. So multiply by x plus 1 and multiply by x plus 2. Okay, you'll notice again I've used this 3 equal sign. You won't get identity symbol. You won't get punished if you don't use it, but it's just a kind of reminder of why later on in the question we can do what we're going to do. So that's going to leave me with 2x plus 3 over here. I think I've got another pen now. And still my identity. And then a is going to be multiplied by x plus 2 now, because when this is multiplied by x plus 1 and x plus 2, the x plus 1 parts are going to cancel out. And then b is going to be multiplied by x plus 1. So they kind of end up with the opposite brackets than they had in the denominator, which hopefully makes sense. When we do some slightly more fiddly examples later, it's really important that you get this. This is the kind of the setup line that's really important. Sometimes for these basic questions, people kind of just learn / remember the patterns. Now again, because it's an identity, we can sub in some values of x. Okay, and this is the easiest way, although not only the only way to solve these questions. So to find a, that was a blue pen, but it's not. Here's my blue pen. We're going to sub in x is equal to, so we want b to disappear. Okay, so we want all this term to disappear. So if we put in x is minus 1 here, minus 1 plus 1 is 0, so all this term is going to disappear. So to find a, we're going to set x to be negative 1. And then to find b a little bit later, we're going to set x. So we want a to disappear this time, so we're going to set x to negative 2. So because in its identity, and this is true for all values of x, we can use this method. As I said, there is one other commonly used method, but I think for the more complicated questions, in particular, this one is definitely the most straightforward. So I'm going to sub negative 1 into the left-hand side here first of all. So that is going to get me negative 1. So negative 2 plus 3 is a positive 1. Usually use my calculator for this. I'll just grab that as well. Don't want to make any mistakes. See, I've named my calculator so nobody steals it. And then if I sub negative 1 into here, that is just going to leave me with 1. So 1a, or just, I'll put 1a, but effectively a. So a is equal to 1. Okay, it'll be the same process here with subbing in negative 2. So 2 lots of negative 2 plus 3. I think I can work this out, but you get the point that I'm trying to be a little bit careful. So that's negative 1 on the left. And then again, like last time I ignored the b term, I knew that was going to cancel. This time when I put minus 2 into here, that's going to cancel out as well. So I'm just going to get left with this term. So negative 2 plus 1 is negative 1. So that's going to equal to negative 1b. And therefore, again, b is going to equal 1. Okay? So we're just looking for those x values that will cancel out a or b. So finally, then I can write it in the right form at the end. So a is 1, so my answer is going to be 1 over x plus 1. So I'm just going back to this idea at the end. And then plus 1 over x plus 2. Okay, and that is my final answer.